So you wanna make an AI in Unreal Engine. You wanna do the idling, investigating, patrolling, and some dynamic combat. Every tutorial is telling you to create these three things, but when you finish it, it's either a part of a long series or a series that has long since been abandoned. Welcome to my ultimate guide to AI. Disclaimer, this video expects from its viewers that they understand the basics of Unreal Engine and blueprints. This video is also a guide, not a tutorial, so you won't see me code everything, rather I will show you everything needed to replicate this while explaining to you what it does. So if you want to copy the code, feel free to pause the video and do so. Let's start with these three things I already showed you. This is an AI controller. All you need to know is that it can start and stop the AI. It also feeds information about AI surroundings to the behavior tree. This is the mentioned behavior tree. It contains a tree of nodes that make the AI's decision making. This last thing is called Blackboard, and it essentially just stores data you need stored for behavior tree's decisions. You can find them like everything else in Unreal. Just right click and type into the search bar what you want. Before I start actually making the logic, we have to talk about rules. Behavior trees start their logic from top to bottom and from left to right. This rule is on top of all the other rules that each behavior tree node has. The root is where the logic starts. First, if I would want to check if the AI is hostile, I would use selector. You might think selector selects and executes only one thing, and you'd be correct. But it's the way it selects you need to know. Selector executes things, but it does so by going from left to right and succeeding if single one executes properly. Sequence, on the other hand, tries to execute everything in sequence. If either part is not executed properly, everything afterwards won't be executed as well. Simple parallel is different, because there is this blue thing we never seen before. These blue things are called tasks, and for now just accept that they exist. Simple parallel can execute this one task alongside a whole tree of options. Also, you can set in details panel if it should immediately abort the secondary tree as task is finished, or if it should wait for the tree to finish as well. Now for the task nodes. Every task is a code just like blueprint that is representing an action. Everything should end with some kind of task, otherwise the AI can be stuck. Also, tasks should always start with event receive and end with either finish execute or abort. Unreal has a lot of these tasks already coded and you should experiment with them. Decorators are conditions that helps behavior tree with the flow of execution, and they can be attached to anything. They often communicate with Blackboard keys to execute what is needed. Unreal again has a nice set of decorators already. Services are the last thing before we can move on. They are like decorators and can be attached to anything, but they are event checks rather than checks. They are often used to update Blackboard keys at runtime. Now I know this is a lot of boring information handed to you in a minute, but it will make more sense as I go through my AI example. Before going deeper, I booted up Elden Ring and did some research. At first, you might think its AI is separated into bosses, NPCs and basic enemies. But to me, it all seemed to be built around one well-made universal AI system. That's why I created an actor component called AI component to hold all the core AI data. This makes it much easier to manage and edit AI behavior later on. Then I connected my enemy blueprint with the AI controller, and also with AI component, and the AI controller with AI component, through which I start the behavior tree. I tested it and it worked. From here, I could start iterating and testing features as I added them. The AI needed to first check if it was hostile towards the player. So I created a boolean in the Blackboard called hostile and added two selectors in the behavior tree. To check whether the AI was non-hostile, I added a Blackboard decorator, set the key to hostile, and set the query to isNotSet. I also enabled aborts, so the AI could instantly switch to hostile whenever the result changed. The non-hostile behavior only had two states: idle, which was just a wait node, and hit reaction, a sequence for when the AI takes damage. To detect when the AI was being hit, I created an interface which allows two different blueprints communicate between each other. In my case, it's player character and AI component. This way, I could send information through a function like who attacked and how much damage was dealt. To add the interface, just go to class settings and add it. I also created an enum containing all AI states I wanted for non-combat phases. Inside the AI component, I received the hit event from interface, which is called upon dealing damage in my player blueprint. I also made a handy pure function, and then stored the attacking actor in Blackboard, while changing AI state to hit reaction. And then updated my health bar logic here. In the Blackboard, I added two variables, but to get them properly, I had to also click this small arrow to open a menu and set one to actor and the other one to my newly made enum. Back in the behavior tree, I added yet another Blackboard decorator to check for hit reaction, which I didn't want to abort because reacting to hit should be a priority, while the idle task should abort whenever AI should react to hit. For the hit reaction itself, I had to create a custom task. Inside it, I added a variable of the type Blackboard key and called it attack in actor. Making it editable makes it so I could link it to any Blackboard key in my behavior tree. With that, I calculated the angle from which the AI was hit. In Unreal, 0 degrees is forward and 180 or minus 180 degrees is backwards, and the minus sides represents the right, while the positive sides represents the left. I realized I'd need another enum for all hit directions, so I could easily switch between them. Using that enum, I selected the proper hit reaction animation, casted it to the character, played the animation montage, and made the task wait until the animation is finished before calling finish execute. For hit animations, I created a map inside the AI component, where the key is direction enum and the values are the animation montages. This lets me easily manage all hit reactions in one place and retrieve them directly into the custom task. The AI should also become hostile when it loses enough health. For that, I created a simple task to change any Blackboard boolean. I also created another task to change AI state back to idle and plug both into the hit reaction logic. To control when the AI becomes hostile, I made a custom decorator called health percentage check. Inside the AI component, I added a hostile HP threshold variable with a slider range from 0 to 100. To make a custom decorator check, I had to override perform condition check AI. Then I simply checked if the current health is less than or equal to the HP threshold. Lastly, I attached this decorator to the hostility task in the behavior tree. Now the AI can't execute hostile behavior until its health drops below the threshold. And to make sure that the task doesn't fail, meaning the whole sequence fails when the conditions are not met, I added a force success decorator to make the task optional. With all of this set up, I could finally test if the hit reactions and hostility transition were working correctly. With the non-hostile behavior finished, I moved on to the hostile behavior, specifically the hostile passive state. This state includes idling, patrolling, investigating, and returning to the spawn point. First, I added two new boolean Blackboard keys for combat state and patrol. Then I copied this to set combat state also to true, because if the player attacks NPC and makes it angry, the NPC should fight back, not just become hostile and do nothing. But it also has to be before NPC becomes hostile, otherwise this would abort and it wouldn't immediately switch to combat. Then I added a selector with a decorator that checks if AI is not in combat state. Inside this selector, I placed another selector specifically for idle and going back to the spawn point, but only if the AI is not currently patrolling or investigating. To make this work, I added a decorator checking patrol state, a decorator for investigation state, so AI will abort this behavior when it should investigate. Lastly, a wait task as a idle, and a sequence for returning home. For the return to spawn behavior, I also added two new Blackboard keys for spawn location and spawn rotation. First, the AI needs to rotate towards this spawn point. For that, I used pre-made task called rotate to Blackboard entry with precision of 1. This might not work properly for you, however. If you don't have disabled in your enemy blueprint, use controller rotation yaw, and also enabled use controller desired rotation in movement component. After AI rotates towards spawn point, it should move back to it. For that, I also used pre-made task called move to, and lastly it should rotate again once it reaches the spot, but now to a spawn rotation. To check whether the AI should be in idle or going back, I had to create a new decorator to check if AI is near specified location. I added an acceptable radius and inverse toggle just for flexibility. You might wonder why I didn't just use Unreal's built-in isAddLocation decorator. The reason is simple: it can't abort when the conditions change. With so many keys being added, I needed a centralized way to manage them. In my AI component, I created a set Blackboard values custom event where I set the initial values like spawn location, spawn rotation, and other key data. This is called in the setup behavior tree event. Now, by simply dragging the AI around in the editor and simulating, you can see it returning to its spawn point. With the idle behavior done, it was time to make the AI patrol. Elden Ring's AI often patrols, so I added 3 patrol types. One-time patrol that follows the route once and then stops patrolling. Loop patrol, which follows the route continuously in a loop. And ping-pong patrol that follows the route and then walks back the same way. To set up a patrol route, I created an actor blueprint containing just a spline to define patrol path. In the AI component, I added a patrol route variable and made it exposed on spawn. I also created an enum for all patrol types. Then I made a find next patrol index function with 4 new variables: a private patrol index and patrol direction, and editable should wait and wait time variables. These two handle if AI should wait after it finishes patrolling before resuming their journey again. The function switches based on a patrol type and then does the logic for each type. In a nutshell, it's incrementing patrol index and getting the next location of spline point while also checking if it's not the last spline point. With the logic done, I created a new behavior task for patrol with 3 Blackboard keys: patrol, point of interest, and spawn location. I also added the point of interest as Blackboard key. Firstly, I called the newly made function and saved the index location as point of interest. Then I handled the waiting, and lastly I checked if it was only one-time patrol, because for that I wanted to turn off patrolling while also updating the spawn location to where it ended patrolling, just to avoid some bugs. In the behavior tree I added the patrol task, which again just handles the data, nothing else. Then I rotated AI towards the point of interest, which is the next patrol point, and lastly, with move to, AI moves towards that point. Now this can loop forever or go just once based on preferences. Investigation takes highest priority within the passive hostile state, so it goes before idle and patrol, meaning its leftmost behavior. In investigation mode, the AI rotates towards the point of interest, moves towards it, waits for like 5 seconds, and if nothing happens, returns to idle, meaning it will first return towards spawn point because it's not near spawn location. To make investigation work, I had to open AI controller and add AI perception component. This is how AI gets data about its surroundings, and for mine, I added 3 senses: sight, hearing, and damage. I don't think I need to explain sight radius, hearing range, etc., because you can hover over it and it will tell you what it is. What I want to point out though is detection by affiliation, which I set to all true in every sense, because I'm not doing group typed enemies for this video. What you should also take into consideration is max age, which just says how long will AI remember what it heard or seen or whatever your sense is. To debug AI senses, first go to your project settings and gameplay debugger to see what your activation key is. Now, when you enable it and press 5, you will see based on the colors you selected in the AI perception the hearing and sight range with many other stuff like if AI spotted player or when was the player last seen. Using report nodes makes AI to actually receive these informations in AI perception. With this data, I can get on-perception updated event from AI perception component, and for each updated actor, meaning AI heard or saw or was damaged by something, I ran a loop and passed the data into three functions: handle damage, sight, and hearing. For the damage function, I first got the correct sense and checked if something was actually sensed. If yes, I saved the sense actor to a Blackboard actor object named target and checked if AI is hostile. If it was, I naturally wanted it to immediately go to combat state. The sight starts the same, but I first checked if safe point of interest is different than this new stimulus location, while also checking if AI is hostile and if something was actually sensed. Then I checked if AI is not in combat state already, because if it is, I don't want to do anything. But if it isn't, I saved the new stimuli location as point of interest and then reset investigation state by setting it to idle and immediately to investigation state. This way, if AI is already investigating and hears something new, it will go towards that new sound. Lastly, hearing is the same, but I checked everything that I checked in sight at one time together, and then I do the same stuff as in sight function. Now to make the investigation system work, I created an investigation service in behavior tree. Remember, these are ticks which can update your Blackboard keys. But before I could code it, I created a new actor object Blackboard key called target and new variable in AI component for aggro distance. In the investigation service, I first checked if target is actually valid, and then I checked if target is currently being perceived by AI. If it is, I set target's location as new point of interest and afterwards check if target is in aggro distance of this particular AI. If it is, I switch immediately to combat state. Now I can finally test the passive state of this AI. First, let's see if patrol works. I open my enemy blueprint and select the AI component. Here I enable patrol and set it to circle looping, and also it should wait for 3 seconds. Then in the world I select enemy and scroll down to the AI component in details panel. Here I can set up patrol route for this specific enemy. To have something to select, I drag and drop patrol route to the world and select the second point. Now I can make the route and add new points by simply holding Alt on my keyboard and dragging. Having made this, I add the route to my enemy and simulate. Now let's try ping pong patrol. And lastly, patrolling just once. You can see the AI turned patrol off and started to just idle. To see if spawn point was updated, let's drag him. Now I will disable patrolling and check if investigation works. For this, in my player blueprint, I just set up 2 events that will make sound and make damage to the AI. When I make sound outside of his perception, nothing happens, but when I do it inside, AI hears it and investigates. Damage on the other hand can be done anywhere, and it immediately switches into being hostile. The only bug now is when I sneak behind him and attack him. You can see AI doesn't care. To fix this, I can add report damage event into AI component interface. To recreate the kind of complex AI scene in Elden Ring, I spent countless hours thinking about the best approach. In the end, I decided to structure my AI around 3 combat distances: far, mid and close. Each zone determines how the AI behaves. For example, in the far zone, the AI can use range attacks or gap closers to get closer to the target, and in close range it can get really aggressive, chaining multiple combo attacks or choosing to create distance to reposition itself. These different zones already make the AI feel dynamic, but that's not everything. I also wanted to make random decisions based on the probability of each action within the zone. This lets me fine-tune enemies to be passive, aggressive or evasive that frustrates the players. The AI's core actions ended up being close distance, move backwards, make distance, dash and strafe, with each combat zone having 3 attack placeholders that can be used for whatever. For me, first one represents single attack, another one combo and the third one is a special attack. The first step was setting up an enum for combat zones and a structure holding all action probabilities. I then made an enum for combat actions, including 3 that are actually reactions: turn towards target, hit reaction and faraway state. Another enum held the attack placeholders, and I created a structure for attack data containing an array of animation montages, the attack type based on the placeholders, attack weight for probability, a health threshold to unlock attacks like a boss second phase, and the min and max angle defining where the attack can be performed. To save myself headaches later, I also set default values for all float variables. With this setup, in my AI component, I created an array of attack data, then array for probabilities for each combat zone, and added 2 floats to define where mid and far zone starts. Close zone begins where mid ends, making it easy to calculate. Next came the decision-making brain, which was the hardest part. I built a service with all the Blackboard keys I'd need, some which didn't even exist yet, but I would create them later. In the event receive tick AI, the first task was to get and save the distance between AI and its target. Then the AI checks for reactions in priority order. First is hit reaction. To implement this, I also added 2 floats in my AI component, a private received damage variable and a non-private poise variable, which determines how much flat damage the AI can take before reacting. I also made 2 functions for setting and getting received damage. And whenever the AI was hit, I updated this via an interface I had already set up. In the service, a pure function checks if received damage is equal to or greater than poise, and if it is, the selected combat action becomes hit reaction, mimicking the behavior of non-hostile AI that switches actions based on an enum. The next priority is turn towards target. Another pure function checks if the AI needs to rotate based on the proper angle. If so, the AI performs a turn towards target action. The last reaction is far away check, for when the AI strays too far from its spawn point. I also added 2 variables in my AI component for this, one to enable this behavior, so bosses wouldn't use it because they don't need it, and another defining the distance at which it applies. A pure function compares the distance to this variable and sets the selected action to far away if needed. I also performed these checks in the event receive deactivation just to prevent some bugs. Once the reactions were set, I moved to selecting proper actions. This happens in event receive search start AI, triggered whenever the selector starts searching for something to execute, or in other words, when the AI finishes its action. I set the control pawn variable, verified that all reactions were false, and then determined the AI's current combat zone using a pure function. With the zone known, I could switch on enum and select actions. I wrote a function that converts all probabilities into an array, then another function that chooses one randomly. By the way, you can use this function to randomly select anything. And then switches on the chosen index to select the action from the action array. For strafing, I also used Blackboard key to switch directions dynamically based on the AI's last strafing move. This can be improved drastically, but for the purpose of this video it's enough. Choosing an attack required a dedicated function. I set selected combo and selected attack to 0. Selected combo maps the attack data index, and selected attack is the specific animation index. I loop through all attacks, checking if the combat zone matches, if the AI health meets threshold, and if the target is within the correct angle. Valid attacks then are stored in the local arrays. After looping, I randomly selected one based on probabilities and returned the attack index as selected combo. Thanks to setting selected attack to 0, it will always pick the first animation index. Back in the main action selection, if no valid attack was found, the AI defaults to strafe. Otherwise, the selected action becomes attack. To handle combos, I created a custom event in the service, checking the same conditions as before. Then I copied a function that chooses random attack, removed the unnecessary local arrays, and ensured the array index matches the selected combo. I also check if the AI is in proper distance for continuing the combo. If true, the AI increments selected attack and continues the combo. I also added checks to prevent infinite loops. For example, if there is only one animation or if the combo is complete, the AI won't repeat it unnecessarily. I also verified that the last action was an attack before continuing the combo. In the event graph, I checked if the combo function succeeded, and if so, I set selected action to none and then back to attack, resetting it and ensuring the AI continues properly. Another critical part is updating the combat zone with every tick. For example, if the target moves closer, the AI should immediately decide its next action, unless it's currently attacking. I tracked the current combat zone in private enum and updated it each tick. Changing the zone forces the AI to search for a new action, with setting selected action to none. For combos, I grab a character reference in the event receive activation AI. Funnily enough, this runs after the search. I also created a montage selection called idle for every combo animation to allow the AI to switch to a new animation if another combo attack can be executed. During the tick in the service, I check if the current montage section is idle to continue the combos. I also had to update turn towards target for special attack angles. If the AI should rotate towards the target behind it, I check if attack is available in that angle and force the AI to select it. This ensures the AI has learnable patterns, but you could also add a weighted random bool check if you prefer unpredictability. After completing the brain, I populated the Blackboard with all the new keys. Then I moved on to creating the action sequences. The highest priority has read reaction, followed by turn towards target, with a task that sets and clears focus. Setting focus makes the AI always look at its target. These two clear the focus. Closing distance focuses on the target and moves forward, with a task to change movement speed based on the newly created movement variables in the AI component. For this, I also needed to create an enum with all the movement types. Moving backwards also uses focus and variable speed, combined with a simple parallel node to move but also end after randomized duration. To make the AI walk backwards while facing the target, I used EQS, Environmental Query System. To imagine what it actually is, create an EQS testing pawn and drag it into the world. Now, when you search in the details panel for EQS, you can set a query template, but there are none available, so let's create one for walking backwards from its target. Now add it as a template and you see nothing. When you open EQS, it looks quite similar to the behavior tree. Again, it starts from the root, and when you drag down from it, you can see multiple options. To see what it actually does, click on anything with points, but for going backwards I will be using grid. Now you see generated points around the testing pawn, and you can also see that it checks for any obstacles by itself. You can get any or specific point by assigning tests by right-clicking. Let's choose a distance test and set float value max to something like 500. You see it filtered the points while also assigned a numbers to it. That is the score, and the bigger the score, the better the chance of selecting that particular point is. If you want just to filter or score, you can change the test purpose. Or if you want it not to select center, you can add minimum to it and it will do its magic. Projection data is used so the points are projected onto the nav mesh and not just everywhere. Up and down is the distance from nav mesh where it can check points for projections. So for example, if you don't want your points projected on a wall, you set this to a small number, maybe something like 300. The offset just offsets points so they are not in the ground because it may cause issues with move to task or any other stuff. Now back to the problem at hand. For moving backwards, I used a grid and filtered points using dot test. For points behind the AI, I set minimum value to -1, which will select everything behind itself. But this is still way too many points, and I needed just a straight line, otherwise AI would move erratically. So I set max value to minus 0.96. The closer the number to -1, the smaller the angle of points will be selected. Now we have points, but they are not scored. To do that, I added another test based on the distance, which will be just for scoring. You see that the highest number we have the points furthest back, which is the opposite of what I want. So the only thing I need to do is set scoring equation from linear to inverse linear. Now I'm gonna set the radius of the simple grid to 800 and also change the navigation filter to recast filter while selecting the post projection offset to 32. Back in the behavior tree, I set the query template to the one I created and set the Blackboard key to point of interest. The Blackboard key is the point that was selected by the EQS. In run mode, I can set what points it should select and I will choose single random item from best 5%. I also want this service to run each 0.1 second. If I didn't use a simple parallel that discards this move to, this task would run forever because it would never reach the point of interest, which is updating each 0.1 second. But to have smooth movement, you have to do it like this. The next action also uses EQS, and that is strafing. Firstly, again, it will focus on the target, then change the movement speed to strafe, and then yet again uses a simple parallel with randomized time, but this time it will have a selector with two move tos. Both are the point of interest, but they also need a Blackboard decorator that checks if the AI should strafe to the left or to the right. Now, because I want the AI to strafe around the player, EQS firstly needs to know who the player is. For that, I had to create EQS context blueprint. I needed to provide just a single actor to the EQS, so I will override that function. Now I just get the target from the Blackboard and send it in. I also had to create yet another EQS context blueprint, but now I needed to provide it with a single location. This one is to check if the points are on the left side or on the right side, and I needed to select just the left side points. So again, I get the target and then I calculate on which side the points are. To get also the right side points, I duplicate this and just change the yaw from -90 to +90. With these blueprints done, I created an EQS for strafe left and generated points on the circle. Then I set space between points to be 150 and the circle center is the target context, or in other words, the AI's target in the Blackboard. The projection data is set to be the same as in moving backwards. To score points, I added a distance test and set it to inverse linear. The last test will be dot, which will be between 2 points, from context strafe left to the context querier, which is the AI using this EQS. Line will also be from context strafe left. Filter type will be maximum with a value of 0.6 and the scoring again inverse linear. Now just copy this EQS for strafe right and the only change is in dot test. Instead of both lines from the strafe left, they will be strafe right. Back in the behavior tree, I added the EQS services, selected a random from best 5%, set the Blackboard key to point of interest, and for the interval I used 0.01. To make sure move to task gets updated point of interest, I had to check observe Blackboard value in all move tos with EQS in this behavior system. Otherwise, it might not get the proper updated point of interest through the EQS. Also, because I wanted to generate points on circle at the target distance and not a flat value, in both strafe left and strafe right I set circle radius to be query params. This lets me in EQS service specify the flat value or set it as a Blackboard key, which I set to target distance. For attacks, the AI doesn't focus on the target continuously. Rotation should only happen during certain parts of the attack, which I will set up later. I also change movement because attack is first and foremost making the AI move into the range before executing the attack. Then I made a task with 3 Blackboard keys. On event receive execute AI, I set controlled pawn to be private variable just so the graph isn't packed with lines. Then I get the selected combo and get its proper distance zone, which I check with combat distance zone. This pure function is the same as in the service, I just copied and pasted it here. If AI is in the proper combat zone, I cast it to character to play any montage, and the montage I want to play is the selected attack. Then I wait until the animation is finished and finish the execute. Because there is actually this delay, I had to set in the service when I did the combo the selected action to none and again to the attack. But it has to be here so the AI plays the whole animation if it cannot combo the attack. Now on the other hand, if AI is not in the correct combat zone, it will first move towards the target and the acceptable radius is where each zone starts. With that done, we have two last combat actions which are almost the same. First is dash and we will focus on the target and use another newly created task with these Blackboard keys. It also needs a new structure which will have just any montage and direction to where AI should dash. In AI component, I had to create an array of dash structure for all dashes. This I guess is based on preference, but I firstly got these private references, then looped through all dashes and switched on combat distance zone enum. I yet again copied this pure function here. Now if AI is in far zone, I want it to dash only towards its target. If it's in the mid zone, it can dash left, right and towards its target again. And if it's in close zone, I only want it to dash backwards. Now the make distance focuses on the target and has a simple task that just plays the anim montage. I also had to make an array of animation montages in AI component for all make distance animations. Finally, the faraway state handles when the target is far away from the AI spawn. Here, the AI focuses on the target, adjusts its speed and does the strafe logic for a few seconds. If the target doesn't come closer, it clears focus, sets AI state to idle and stops the combat. Changing AI state to idle makes it return to spawn. But this has to be done before AI stops combat, otherwise it would abort this and never execute this task. To test combat, let's first add attacks that AI can use for every zone. I will use the first in each zone for single attacks, the second for combos and the last for special attacks. But let's not forget that close zone 3 is set up to be attack that can be used when target is behind the AI, so that one will be for that. Now I set far zone to start in like 850 distance and mid zone in 400. In the far zone I mainly want it to close distance, but it can also use some attacks. Mainly the gap closer one. Let's also add strafe and dash. For mid zone I want it to mainly strafe while having bigger chance to use mid zone attacks. I will also allow the gap closer here with dashing and closing distance. And in the close zone, I want AI to mainly use combo attacks, but it can use mid-zone attacks while being able to dash or move backwards. I sadly don't have animation for making distance, but I will use dash backwards for that. Future me here, before we go to the testing, I really hated how moving backwards was so jittery, so I had to redo it. Instead of using expensive EQS that didn't even work properly, I made a service with these Blackboard keys and calculated retreat direction and then made a box trace that checks for everything in the path excluding itself. If there is something, I just selected combat action to none so AI will decide on next action. And if it can go there, I update the point of interest. I set the service to run and check every 2 seconds. There are also two things that were making some stupid bugs. One is in the bring combat service in check combo function. I forgot to add return node without success on loop complete. If you won't add this, the AI might succeed if it loops through everything, but if it does so, it hasn't found any attack, so the last attack might loop. Lastly, in play dash montage task, there is no shuffle before we loop through array, which means, for example, in mid zone, it will always pick the first animation it finds, and the first animation is always the same. And now back to the testing. Now just as a bonus, I will show you how I handled animation part of turning towards the target and rotating AI towards player while attacking. In the animation blueprint for my enemy, I calculated how big is the angle to where AI has to rotate by getting his current rotation and his new designated rotation. Then, in locomotion, I simply use two states for left and right animation with transition rules that check how big the angle is. For attack rotation, I made two anim notifies and used it in every attack anim montage. And yet again, in animation blueprint, I set a gate that opens and closes based on notifies, and then get the target from Blackboard and rotate towards him with reinterrupt 2. With everything done, you can see there are numerous things I can adjust through the AI component, like hostility and its threshold when it becomes hostile, patrolling, aggro distance, all of the attacks it can use, all dashes, all movement speeds, hit reactions and when it should react to the hit based on the flat damage, ROA state and when it should apply, make distance animations, and mainly how the AI should behave when it's in combat. This is quite a lot, but there are still so many things that you can adjust or add to make it even better. I wasn't making this with the mindset that I'm gonna make the best AI, but only good enough base for everybody, because no matter how hard I looked, there wasn't any really dynamic AI tutorials anywhere. If you have made it to this part, I cannot thank you enough for your time. Hopefully this video taught you something, and if yes, consider liking, sharing, or commenting what you liked or what you didn't. All feedback is appreciated. I want to make more guides that cover topics fully, so I also made a Patreon where you can support this unemployed student. There you can find project files for this and more upcoming stuff. The project file doesn't only have AI, but also the player part that you've seen in this video. The only thing that it's missing are the animations, because they are bought from the store. You can find link in the description if you like them, and well, that's it. See ya!